In this module, we will dive into the template method pattern. Its intent is to define a skeleton of an algorithm in an operation, deferring some steps to subclasses. This pattern is actually one of the fundamental techniques for code reuse. I dare to guess that you've already used it hundreds of times. Let's have a look. We'll start by describing the template method pattern. For that, we'll use a real-life example. Parsing mail for a startup company's software that wants to revolutionize the way we look at email. We'll map that to the pattern structure and we will implement it in a demo. We'll continue with learning about use cases for this pattern and pattern consequences. We'll end the module by looking into related patterns. Let's describe the template method pattern next. The template method pattern is a behavioral pattern from the Gang of 4 library of design patterns. Its intent is to define the skeleton of an algorithm in an operation, deferring some steps to subclasses. It lets subclasses redefine certain steps of an algorithm without changing the algorithm structure. Let's clarify that with an example. Imagine that we're writing part of an application that wants to make working with email easier by accumulating mail across different mail servers and analyzing them. The idea is that the company's proprietary artificial intelligence will ensure that your inbox surfaces the mails that are important to you. To be able to do that, the software must connect to different mail servers and parse mails. So we've got a few classes: Exchange Mail Parser, Apache Mail Parser, Eudora Mail Parser, and so on. For the sake of the demo, we will assume that a parser parses one HTML mail at a time by accepting an identifier. The thing is, a lot of what has to happen in the algorithm to parse one mail is the same for these three classes. First, the server needs to be found. Then we need to authenticate to the server. That's probably a bit different for each implementation. Then the mail body must be parsed. And that's exactly the same for each of these parsers. We don't want that kind of code duplication. What we can do is create an abstract base class with a template method on it. That template method, parseMailBody, accepting an identifier, calls the other three methods in a certain order. The other three methods are thus also defined on this abstract class. Subclasses like Exchange Mail Parser or Eudora Mail Parser call this template method on the base class to parse a mail. Yet, we allow these subclasses to vary the algorithm by overriding abstract methods. We could make the authenticate to server method abstract, because this differs for each class. That means that each subclass must implement this method. Moreover, we can also allow subclasses to optionally override the other methods as well, in case they would require changes by making them virtual. In Gang of 4 lingo, these methods or operations are called hooks, and findServer is one of them in our example. The only thing that absolutely must not be overridden is the template method itself. And that is what the template method pattern is: a straightforward, often used pattern in OO design. Let's map this to the pattern structure. There's only two players in this pattern structure. The first one is the abstract class. That's our mail parser. This defines abstract primitive operations that concrete subclasses define to implement steps of an algorithm. Our authenticate to server method is an example of that. A variation is that not all methods are primitive operations that are abstract and thus must be overridden. Some of these methods can be made virtual so they can be overridden, if needed. The other methods, optionally, could be examples of that. The abstract class also implements a template method, which defines the skeleton of the algorithm. In other words, the order in which the other methods are called. It thus calls primitive methods as well as other methods defined in an abstract class or on other objects. The second player is the concrete class. This implements the primitive operations to carry out subclass-specific steps of the algorithm. They map to our Exchange mail server, Apache mail server, Eudora mail server, and so on classes. And with that, we've got our pattern structure. Let's implement it. In this demo, we'll implement the template method pattern. We'll start with an abstract class. That's the abstract class component from our diagram, and we name it MailParser. On it, we define 3 different methods to start with. FindServer is used to find the mail server. This method tends to be the same across concrete implementations, but we mark it as virtual just in case there's a mail parser for which this differs. AuthenticateToServer is abstract. This is a primitive operation which differs for each subclass. We want subclasses to implement it, and that's why we mark it as abstract. And then we have parseHTML mailBody. This method remains the same across different implementations, so we don't mark it as abstract nor as virtual. And then we add one more method. We name the method parseMailBody, and this is our template method. In it, we define the algorithm by calling the other methods in order. That's it for our abstract class. Now let's create concrete implementations of it. We start with the Exchange implementation. Here we override one method, the abstract one, to authenticate to the mail server. The Apache mail parser follows likewise principles. We only need to override the abstract method. And then we have the Eudora mail parser. This one is slightly different. We're assuming that finding such a server takes a bit more effort. Luckily, we can override the virtual FindServer method from the base class to achieve this. Note that the template method, parseMailBody, is available on all these classes through their base MailParser class. That's the one clients will use. Nothing what we did changed the order of what's in that method, and we cannot override it nor change it. That's it for our pattern implementation. Let's test this. The first thing we'll try is our Exchange mail parser. We need to import the template method namespace for that, so let's do that. And on it we call the template method, parseMailBody. We pass through an identifier as well. This one will be written out to the console window, so like that we can nicely see what's going on. And then we do the same for the Apache mail parser and the Eudora mail parser. When we run this, we should be able to nicely see that subclassing the base class and overriding an extra method for the Eudora mail parser will have an effect, even though we are calling the same template method 3 times. Let's give that a try. And there we go. As we notice, the AuthenticateToServer method is different for each of these implementations. And we also notice that for the Eudora mail parser, finding the server is different as well. With that, we know how to implement the template method. Let's have a look at the use cases for this pattern. Use this pattern when you want to implement invariant parts of an algorithm only once and want to leave it to subclasses to implement the rest of the behavior, the parts that can vary, like our AuthenticateToServer method. Also, use it when you want to control which part of an algorithm subclasses can vary. Those are the methods that you make virtual or abstract. Lastly, use it when you find yourself in a situation where you have a set of algorithms that don't vary much. Maybe only in 1 or 2 methods. Those, again, are the methods you'd make abstract or virtual. Let's have a look at the consequences. Using this pattern comes with a few consequences. First of all, these template methods are a fundamental technique for code reuse, especially when creating class libraries. That's because template methods are how you factor out common behavior by pulling it out into a parent class, thus removing code duplication. A potential negative consequence is that template methods cannot be changed. The order of the methods they call, the skeleton, is fixed, and that may be too strict for some clients. Time to look at the related patterns. Factory method and template method are related patterns. You can even look at the factory method as a specialization of the template method, aimed at object creation. Also, often template methods use factory methods as part of their skeleton structure. It's also related to the strategy pattern. Both are used to vary an algorithm. Template method allows varying part of an algorithm through inheritance. The subclass implements the abstract base methods. It works at class level, so this is static. Strategy, on the other hand, is based on composition. By providing different strategies, the object's behavior can be altered. It works at object level, so it's dynamic. Behaviors can be switched at runtime. Time for the module summary. In this module, we covered, arguably, the most often used behavioral pattern, the template method pattern. Its intent is to define the skeleton of an algorithm in an operation, deferring some steps to subclasses. It lets subclasses redefine certain steps of an algorithm without changing the algorithm's structure. As far as implementation goes, the template method must be defined on the abstract base class and cannot be overridden. Methods that differ per subclass must be marked with the abstract keyword and must be implemented in subclasses. Lastly, you may let subclasses change base behavior by marking some methods as virtual. Up next, the strategy pattern, one of the patterns related to this one and also very commonly used.